if the appropriate detection will be done, then by using a vulnerability manager, management software, or some other software, again, the information about the host will be able to be collected, and the information that I need in order to assess the security of that particular element will be gathered, and also the ability to quarantine the element through something. So I don't have an agent, I don't control the calls, I don't control the element. So the last thing that I have here to do, since I do not control the DHCP, is to interact with the switches. So in most of the cases, I need to know where the switches are, because believe me, they are not on my local network, they do not share the same IP address, they will be managed through another subnet usually. And when you come to the organization that may have 3,000, 4,000 elements, you may have 200 switches, and understand who connects where, that's a huge problem. So unless I understand which element is connected to which switch exactly, quarantine these elements, well, it's very questionable. So weaknesses here, you have to deploy, you have to have access or information from each and every subnet. You must know what are the different subnets for an organization, what are the different locations you need to be deployed at. In some cases, I hear vendors that say, well, we come to the client and we ask the client to provide us with this information. Well, you buy a security software, you buy something that needs to secure your network, and you need to rely on information that is with the organization. And I guess that you all know that this information is usually partial. So in most of the cases, well, 70% of my network will be covered, but what about the 30 other percent? So the other venues to access that particular network may also be there without the knowledge of the IT network, because we don't understand how our network looks like and we don't know all the information about it. Already talked about the switches. Still, network access, network address translation, the word access. Too much, I'm saying that too much today. Network address translation is still a viable venue to bypass the solution. Yes, I authenticate with one machine, but I connect to it my laptop from home, and I'm still able to access the network and get to where I want. Still, exceptions are being done according to MAC addresses, because there's no real knowledge regarding the real operating system that sits behind the element, and also sometimes having that information is not enough as well. So just look at your printers, which needs to be connected to the network and allowed on the network. Understand what they're doing. Just a nice venue to access the network without being detected and just abusing the MAC address and IP address of these. Another interesting venue that we touched before is the ability not to generate broadcast ARP traffic. And I found out that if you, instead of sending the ARP request to the broadcast address, but sending it directly to the MAC address of the element you want to talk to, that works fine as well. The element will receive your ARP request, will communicate with you, no problem. No broadcast traffic whatsoever. No one will see you on that network. So still, you are on that network. You can infect all the local subnet. Nobody knows that you're there. And everything is happy if you're the attacker. The problem with unmanaged elements here is much more severe because of the need to interact with the different switches, their need to understand how the network looks like. If you don't know where the switches are, if you don't know where the elements are connected to, if you're unaware of these, then these elements will not reveal themselves to you. Questions before we go forward? Yeah. You can do that. You can introduce an out-of-band solution. We will touch that later on. These also suffer from some other. Well, basically, you can say that all the problems that you see here are also shared with the out-of-band solution, because the type of information that you will see, especially if it's deployed at the access layer, will be the same as the broadcast listener. The same problems. if the out-of-band solution will be using a passive port which is after the router, meaning it will look only at IP traffic, that will be useless. Because then you'll also be missing, yeah, it's back. Then you'll be missing also crucial information such as the MAC address of the elements. And then when would you like to reference the information that you get from the network, you will not be able to do that. Question here, yes? Yes. Yes, you're right. I wish I could have something to give you, but there's nothing here. We'll be talking about that. Usually when you are on the network, you're able to do some stuff. So you can't be denied of doing some stuff. So basically you can abuse, and that's absolutely correct, you can abuse the ability to send, for example, DNS, and I won't ruin you the surprise for later, but the idea is that you can abuse those to tunnel your traffic through wherever you would like on the network. So if you have other people that may help you with your endeavors to break into that particular internal network, then you can bypass information tunneled through that through that particular port and do whatever you would like with the type of information, or to try to compromise those systems on that particular network which may have DNS installed. Other questions? Okay. Vendors. I must, or do you insist? Okay, vendors. McAfee, for example, all of those that only watch out-of-band traffic, Mirage Networks, for example. Sorry? I don't know them, but, oh, okay. If you're saying, I'll believe you. But basically, you can understand that as well yourself. I put that as a fun part. I'll try to be very brief because we're late. SNMP traps, who knows this type of solution? Basically, it's saying, okay, you know what, I have a bunch of switches. I'll configure them all to send me SNMP traps when they register a MAC address on one of the interfaces. So I'll know a new element is connected to the network, and everything will be fine since I know this element and I can do other things to it. Well, basically, that's another very big mistake, because the type of information that you get back, and especially this is all true with Cisco, since Cisco has this ability built in with any iOS whatsoever. It's a good ability, but not for network access control. And they don't aim to that people will use it for network access control. It means that when you can basically set up SNMP traps on a switch, and basically when the interface register a new MAC address on that particular interface, it will send you an SNMP trap saying on that interface that MAC address is now being registered. The problem is that you will be receiving multiple SNMP trap information from all of the switches that may register the particular MAC address, and you will not be able to understand the exact location of that particular element. So that will be fun. Also, that particular issue even suffers more from broadcast listeners, because here, if you don't know where the switches are, you will not be getting this type of information. So if you don't have any adequate information regarding your network, that will be proven useless. As a matter of fact, not all switches supports this type of notification, so at the end of the day, you will not be able to get the information from all of your infrastructure. And in most cases, most of the organizations that is, well, at least that I have met, may have hybrid networking gear from multiple networking solution manufacturers. So some of them may be able to support it, some of them may not. Basically, all the other problems also there. So we got to one of the funniest part of the presentation that I guess most of you came to see. It's okay, but not. You'll see the problems. Basically, Cisco, I think they were the first to introduce the concepts of 802.1x and network admission control, as they term it. I like to say in advance that 802.1x is the, from all of the element detection and the abilities to quarantine the user, is the best technology that is out there. Nothing is compared to that, especially when it is deployed correctly, and we will see when it is not. Needs to have a Cisco Trust Agent, basically an agent software that is installed on Windows-based machines or Red Hat 9. the Cisco network access device, basically a router or a switch which has the appropriate iOS on it that supports network admission control, and the secure access control server basically says whether you're compliant or not with what needs to be determined. There are like 3 enforcement strategies with Cisco. First of all, it's NAC L3 IP, basically only deployed on routers, triggered by an IP packet. There's NAC L2 IP, triggered by either a DTP packet, a DTP request, or an ARP request. Applies per interface of the switch or router. And there is the NAC L2 802.1x, which is basically triggered by any data link packet that may reach the interface, and then the network access device knows that you're there. A lot of blah, blah, blah. Basically, very good way to secure the access, to the network. Very good encryption and all protocols. It's not the point of failure, although in that respect, when the element is able to interact with many different components on the network, and you all remember the talk of last year that spurred out a lot of talk by Mike and Lynn about the iOS problems and everything. You know that interacting with switches and routers can be hazardous. Also, when you need to interact with remediation servers, they will also be a good target for that. So that's also a possibility to attack them, but this is not what we're going to talk about. NAC L2 802.1x, that's the best thing that you can deploy, as long as it's deployed on switches. And it is deployed on switches, and basically when your switch is the access switch, that's the best thing they can have, because before an element has an IP address, it's basically quarantined, it cannot do anything, and you are able to fully control the element. It's also, I see it as a good thing when a security technology is embedded inside the networking gear, and in the case of Cisco, that's a good thing. Also, their ability to put different cards inside the 6500s and do other security stuff is very good, because you don't have to introduce other boxes to the network and other things to the network. But it also has many different weaknesses. First and foremost, it works only with Cisco equipment. So if you don't have a Cisco equipment, or you're a hybrid shop, then basically you are not able to deploy that, or you can deploy that but partially. 802.1x is usually very difficult to manage. It's not an easy thing. If you try to go over the different deployment and configuration guides by Cisco, it's not trivial. Especially also that not all of the networking equipment that you may have on the network may support this. You may need to upgrade it or replace it. Is a cost that also needs to be associated with it. And also, not all of the elements that may reside on the network can do 802.1x. Sorry? What do you mean by non-Cisco? Sure. Yes, but I'm looking at Cisco. I mean, I said earlier in the start of the presentation that we'll be looking at different vendors, different architectures. I may not be looking at all of them, but you're correct. There are 802.1x that are non-Cisco. There are companies who, other other networking gear manufacturers that do 802.1x at the access layer, the access switch. These are all good solutions. I'm not saying that they're bad. I'm talking here about what Cisco does. So if I have a component on the network that is not able